Hi. Since I actually work and live about an hour away from the Hartford campus, I've decided to give my update using the video option. To recap, my final project is focused on analysis of a cantilever beam. As we all know, they're fixed on one end with the rest of the structure free, and for simplicity, I'm going to be analyzing these with point loads along the length of the beam. The inspiration for this project was the laparoscopic surgical instrumentation that I work with, which are typically long, thin metal or plastic shafts inserted into a patient through a fixed port. The working parts of the instruments are typically located on the tip for things like cutting, grasping, clamping, tacking, and so on. And so most of the forces we end up seeing on these instruments are applied at the farthest end away from the fixed point. Taking Ernesto's advice, I've chosen to focus more on the finite element analysis than on the underpinning theories of cantilever beam bending. Theory is great, but I do agree that the actual analysis and application that we build off of those theories is what ends up mattering most in industry. To that end, I've developed some simple cylindrical models in COMSOL using one face as a fixed constraint. I'm currently looking at 5mm, 10mm, and 12mm diameters, which are industry standard for laparoscopic instruments. I'm using lengths of 33 centimeters, which is a standard length, and 45 centimeters, which is the length that we use for bariatric patients who need a little bit more working length to really reach all their internal structures. As far as materials go, I'm looking at a variety of surgical grade steels and titanium, as well as polycarbonate and PEEK for our plastics. PEEK isn't actually typically used in these types of applications with these types of loading schemes since it's a bit more brittle, but I figured it would be interesting to model it, see what happens, and give an illustration of exactly why we don't use brittle materials. So I'll be comparing a number of models with various geometries and various material properties. So that's about it for the update. Thanks, and have a great day.